In economics, incomplete markets refers to markets in which the number of securities is less than the number of states of nature. In contrast with complete markets, this shortage of securities will likely restrict individuals from transferring the desired level of wealth among states. How do we overcome this incomplete market? In practice, the idea of state contingent security for every possible state of nature seems unrealistic. For example, if the economy lacks the organisations to guarantee that the contracts will be enforced, it is unlikely that the agents will either sell or buy these securities. Consider this example where markets are incomplete. There is a bond and stock and 3 time states: good, fair and bad weather. Suppose that an investor asks an investment firm to create a product with a set payment C. Since the payment matrix is a 3x2 matrix, it is not invertible. Hence, solving for a solution to the set claim C is impossible. To complete the market, we drop the 3rd time state, being bad weather, and solve the 2x2 matrix solution. No markets are sufficiently complete to do it. Using the equation, n is equal to Q inverse C, and following the required sufficient steps, one will establish the value for the price of the portfolio, n. It costs a number of present apples to purchase the portfolio, and that will cover all future outflows. Hedging at minimum cost. Hedging is the process by which one makes an investment to reduce the risk of adverse price movements of an asset. It requires taking an offsetting position in a related security. Recall our original example where markets are incomplete. In order to hedge at a minimum cost, we must construct the cheapest portfolio N. That will deliver at least as much as C in every state of nature. A constrained optimization problem we have to solve is given by minimum N at the price security times N, subject to Q times N greater than or equal to C. No one uses the sign greater than or equal to indicate that every element of vector Qn is no less than the corresponding element of C. We are facing a linear programming problem, or simply the problem of finding a vector that minimizes a linear function subject to linear constraints. MATLAB's command function linprog provides one with the ability to solve such a progression. Enter the data in MATLAB's command prompt. Call the linear progression function linprog, i.e. n is equal to linprog, open bracket ps, comma q, comma c, close bracket. The result to this command is the vector n. The price of the portfolio is P is equal to the price of security times N, which gives you the price